Hello, hello, we're back at it again today with dividing rational expressions. I'm just going to start off by looking at this division problem of regular fractions, no variables. When you divide regular fractions, you keep the first fraction, change the sign to multiplication, and then flip the second fraction. So I flipped that 1/4 to 4/1. I can simplify before I multiply, so I can reduce that 4/2 to 2, and then I just have 2/1 left over, which is just 2. I can use those exact same steps for dividing rational expressions when you've got a bunch of variables in there. So you're going to keep the first expression, change the symbol to multiplication, and flip the second expression. When you have a polynomial over a polynomial, you're going to have to factor absolutely everything completely until it can't factor anymore. Then, once you factor everything and you've kept the first expression, you changed the sign to multiply, you flipped the second expression, you have a multiplication problem. So here you can cancel like quantities as long as you have one in the numerator and one in the denominator. So let's take a look at this first example. We're going to keep the first fraction, change the sign to multiplication, and flip the second fraction. When I'm doing this process, I like to factor as I'm doing this, but you can split this up into two separate steps. So I know that this is going to factor into a set of parentheses. I'm looking for numbers that multiply together to give me 16, but add together to give me 10. So 8 times 2 is 16, and 8 plus 2 is 10. Do the same thing in the denominator. I'm looking for factors that multiply together to give me 8, but add together to give me 6. So that's going to be 4 times 2 is 8, and 4 plus 2 is 6. If you had a number in front of x squared, you'd need to split the middle term. So I can only use that shortcut when I'm using factor trinomials where a is 1. I went ahead and canceled like quantities so that what's left is x plus 8 over 1, which is just x plus 8. For this next example, you are going to need to factor everything. This one is definitely a little more difficult than the first one. You need to make sure you're checking for a GCF first. Check for your methods of factoring, narrow down your options, and you figure out what method of factoring you need to use. The hardest part here is factoring, and this is something that you've probably already learned how to do. Pause the video here, factor everything. It might take you a little bit, but get it done, come back, and we'll check it. Okay, so in the first numerator, we had to factor out a GCF of 2, and then we had to factor using split the middle term. Pause and check your process there. Make sure you have the same factors. Then the second one in the denominator, I did in green in the middle. You had to factor out a GCF, which was 2, and then you had to split the middle term. You can pause here and check those as well. And then the last one in the denominator was also split the middle term, which is in purple. There was no GCF, so you could just factor by splitting the middle term. Notice that I flipped the second fraction as well, so I did keep, change, flip in the same step where I factored, and that 40x plus 48, which has a GCF of 8, is factored in the denominator of the next step. All right, so now we can cancel like quantities like 5x plus 6 and 5x plus 6, 3x minus 10 and the other one, x plus 3 and 2, so that all that is left here is x minus 1 in the numerator and 8 in the denominator. So that's my final answer, x minus 1 over 8. All right, so one more time on your own, you're going to make sure that you factor everything completely, keep, change, flip, cancel like quantities, and come back when you are finished. Pause the video here and try it out. When you're looking at those two quadratic trinomials, you want to factor by splitting the middle term. So you do need to multiply the first and last terms together. You get a new term that you're going to list the factors of, and then you use those factors to split the middle term and then factor by grouping. So in the first one, I split the middle term into 2x minus 27x. That still adds together to give me negative 25x. In the second one, I split the middle term into negative 3x minus 30x. Because your new term, 90x squared, is positive, and those factors have to add up to a negative 33, that means that both factors have to be negative. From here, you have to factor out a GCF from both groups. So that first one is just x, and you're left with 3x plus 2 left over. The next one is negative 9. So you could put in your calculator negative 27 divided by 3. That would give you negative 9. That tells you exactly what you need to factor out. And then those two terms that are in parentheses should be exactly the same. And then whatever's left is your other factor. So you can do the same thing with this second one. You can take out an x from the first group. You can take out a negative 6 in the second group. Okay, you can divide negative 30 by 5, and that gives you negative 6. And that gives you exactly what you need to factor out of that second group. 5x minus 3 is the same. So that's one of your factors, and whatever's left is your other factor. From here, I'm just going to write those factors where they belong in the rational expressions. Remember that when you're dividing, you need to keep the first rational expression the same. You need to change the sign to multiply, and then you need to flip the second expression. So notice how that 5x minus 3 went to the denominator, and then my factored form of that quadratic trinomial is in the numerator. Now you can start canceling like quantities, and you write down what's left over, which is x minus 9 times x plus 6 in the numerator and a 9 in the denominator. You cannot cancel out those 9s. Okay, that is an x minus 9 over 9. You cannot cancel that. They are not the same exact term. So that's it. Have a great day. Practice, practice.